Okay, so get ready because today we are diving deep into the world of oceanography.
Literally.
Yeah, literally. We've got some seriously interesting sources here,
Yeah.
and they're all about, the chemistry of life in the ocean,
Oh, yeah.
the tech that we use to explore it,
Yeah.
and even how the ocean, affects the weather.
That's right.
We're going to break down some of the complex concepts, but don't worry, we're going to keep it fun and engaging, I promise.
Absolutely. It's a fascinating field.
So the sources that you sent me cover a bunch of different areas of oceanography. We've got marine biogeochemistry,
Okay.
we've got marine meteorology,
Okay.
and we've got marine technology.
Sounds good.
So yeah, we're going to be talking about things like how the ocean influences the weather patterns,
Right?
what kind of cool gadgets scientists are using to explore the deep sea,
Exciting.
all that good stuff.
I'm ready.
All right, let's dive in.
Okay.
So first up, let's unpack this term, marine biogeochemistry.
Okay.
Sounds a little intimidating, right?
A little bit, yeah.
But it's actually super cool.
Oh, it is.
It's basically all about how chemical substances move between living things and the ocean.
Yeah, it's this really intricate system of exchanges and cycles, you
Yeah.
know? And what's fascinating is how these exchanges impact everything from the food chain
Uh-huh.
to the ocean's ability to absorb carbon dioxide from the atmosphere.
Oh, wow.
For example, there are these tiny organisms called phytoplankton.
I've heard of those.
They play a massive role in the carbon cycle.
Wow.
They take in carbon dioxide during photosynthesis, just like plants on land,
Yeah.
and release oxygen.
That's incredible.
It's pretty amazing, right?
Yeah, so it's like a giant underwater recycling system.
It really is.
And it kind of reminds us that everything is interconnected,
Exactly.
which is a good segue into our next topic.
Oh, okay.
Marine meteorology.
All right.
So this is all about the weather.
Right.
You might not think that the ocean has, a lot to do with the weather,
Yeah, at first you wouldn't.
but you'd be surprised.
Oh, absolutely.
So tell me about this.
Well, the ocean and the atmosphere are constantly interacting,
Okay.
exchanging heat and moisture.
Uh,
And this interaction drives weather patterns,
wow.
creates storms, and even influences long-term climate change.
So like hurricanes, for example.
I think that.
I was reading in one of the sources that they form over warm ocean waters, right?
Yeah.
And they draw energy from the heat and moisture.
It's incredible, isn't it?
Yeah,
So understanding the ocean is crucial to understanding and predicting these powerful storms.
that makes a lot of sense.
Yeah.
Okay, so let's move on to something a little bit more, techie.
All right, let's geek out a little bit.
Yeah, let's talk about marine technology.
Love it.
So we're talking underwater robots,
Mhm.
high-tech buoys, satellites peering down from space.
All of that.
It's really incredible the technology that scientists are using to explore the ocean these days.
Yeah, it is. And these tools allow us to map the seafloor,
Uh-huh.
measure ocean currents, track marine life,
Wow.
and collect all sorts of data that help us understand this vast and complex environment.
So can you imagine piloting a remotely operated vehicle through a coral reef
Oh, man.
or analyzing data from a satellite orbiting hundreds of miles above the Earth?
It blows my mind.
Yeah, it's like something out of a sci-fi movie.
It really is.
So we've covered a lot of ground here today. What are your big takeaways from all this?
I think the thing that really stands out to me is the sheer scale and complexity of the ocean.
Yeah,
It makes you wonder what else is out there waiting to be discovered.
right.
What new technologies will be developed to help us explore it further?
That's a great question to ponder, I think.
Yeah.
And after this deep dive into these sources, I'm left feeling a sense of awe
Me too.
at the power and the mystery of the ocean.
Absolutely.
And I'm also feeling a sense of responsibility
Yeah,
to protect this incredible resource.
it's vital.
So I hope this deep dive has sparked your curiosity about the ocean
I hope so too.
and the incredible work being done to study and protect it.
Me-
There's a whole world of knowledge out there just waiting to be explored.
It's true.
So keep exploring.
Keep learning.
And thanks for joining us for this deep dive into the world of oceanography.
It's been pleasure.
It's been a pleasure talking to you.
Likewise.
Until next time.
See you then.
Welcome back, everyone. Ready for another deep dive?
Always ready to dive in.
Well, today we're going deep into the world of oceanography,
Oh, yeah. Love this topic.
but with a bit of a techie twist.
Intriguing.
We're talking about two pretty amazing technologies.
Okay, let's hear it.
Particle image velocimetry, PIV for short, and X-ray fluorescence.
XRF.
Right, XRF.
Yeah, I'm familiar with both of those.
Cool. So basically these technologies are giving scientists,
Totally new ways to study the ocean.
ways we couldn't have even
A
imagined.
few decades ago, it's incredible.
All right, so let's start with PIV.
Okay.
So imagine,
It's like giving ocean currents.
yeah, like a roadmap or something,
Exactly. We can actually see how water moves.
using lasers.
And these super high-speed cameras.
Like we're watching a slow motion replay of the ocean.
Super cool, right?
It's way more than just cool. It's super useful.
Oh, yeah. How so?
Well, for instance, think about pollutants.
Okay. Yeah.
PIV can show scientists how those pollutants travel, so we can like predict where they'll end up.
Exactly like with the Deepwater Horizon oil spill.
Oh, right.
PIV was essential in figuring out
Where the oil was going?
and how to best contain it.
Wow, that's pretty powerful.
It is.
So, okay,
Now that's a cool one, too.
it's like having X-ray vision for the seafloor.
Yeah. But instead of seeing bones,
It just shows you the chemical makeup of everything down there.
the sediments, the rocks, you name it.
And why is that so important?
Oh, tons of reasons.
Okay, like what?
Well, you can learn about past climates.
Oh, wow, really?
Yeah, the chemicals trapped in those sediments.
They act like a historical record.
Precisely.
That's amazing.
You can also find pollution hotspots
Oh, right.
and even search for valuable minerals.
Like what kind of minerals?
Things like manganese nodules.
I've heard of those.
They're a big deal right now. Lots of potential.
Wow, so XRS is pretty powerful.
Definitely.
But are there any downsides? Like, can it tell us everything?
Well, it can identify what elements are present, but it doesn't always tell us how they got there.
So, like, we could find mercury,
Right. And we'd know it's there.
but we wouldn't know if
It's
it's
natural or from pollution.
makes sense.
It's a fantastic tool
But we need other methods too.
to get the whole story.
Totally. So, both PIV and XRF.
They're like opening up these new frontiers in oceanography.
And who knows what we'll discover next?
That's the exciting part.
Exactly. The ocean is full of mysteries.
And with these tools,
We're getting closer and closer to solving them.
I can't wait to see what we learn next.
Me too. Thanks for joining us for another deep dive.
My pleasure.
And to all you listeners out there, what mysteries of the deep are you most curious about? Let us know. Welcome back, deep divers. Ready for another plunge into the world of oceanography?
Always ready.
Well, today we're trading our scuba gear for, well, something a little more high-tech.
Oh, intrigued. What do we have?
We're talking mass spectrometry and seafloor drilling. Two techniques that are giving us a whole new perspective on the ocean, like way beyond what we can see with the naked eye.
So like the microscopic world of the ocean and its history?
Exactly. One's like a chemical detective and the other, well, it's practically a time machine. Both are amazing in their own right, but together, man, they're unstoppable.
Okay, I'm hooked. Let's break it down. Starting with mass spectrometry, what's the deal with that?
So imagine you have this like massive bag of Skittles, and you want to know exactly how many of each color are in there.
Okay, that's a lot of Skittles, but I'm with you.
With mass spectrometry, we're doing something similar, but instead of colors, we're separating molecules by their weight. Well, their mass-to-charge ratio, to be precise.
Ah, getting technical.
Yeah, a little, but bear with me. It's pretty amazing. So scientists can use this to identify and quantify, all sorts of molecules in a sample of seawater.
So we're not just seeing what's there, we're understanding how much of it there is. That's pretty powerful.
Totally. And it lets us track, like, the movement of nutrients, pollutants, even gases within the ocean.
So like a fingerprint for each element and compound in the water.
Yeah, exactly. It's
Yeah.
revealing these, like, super intricate connections in the ocean that we never even knew existed.
Okay, I'm seeing the potential here. Got any real-world examples, like how this is actually being used?
Oh, tons. For example, researchers used mass spectrometry to track a pesticide called atrazine.
Atrazine, isn't that used in agriculture?
Yeah, on farms. And they found it was traveling all the way from rivers to coral reefs, miles offshore.
Wow, that's a long way to travel. And not good for the coral, I imagine.
Not at all. But that kind of insight helps us understand the impact of human activities on the ocean.
Yeah, it shows how interconnected everything really is.
Okay, ready to switch gears. Let's talk seafloor drilling.
Time machine time. I'm ready.
Picture this. A giant ship, miles of drill pipe, all to extract these incredible sediment cores from the ocean floor.
Sounds intense. What are these cores exactly?
Think of them like layers of a cake, each layer representing a different period in Earth's history. And these cores can be hundreds of feet long.
Okay, so each layer is like a snapshot of the past. What kind of information can we get from them?
Oh, all sorts. We're talking Ancient climates, ocean currents, even extinct organisms, all preserved in those layers of sediment.
Like a history book written in mud.
Huh, yeah, something like that. And by analyzing those layers, scientists can piece together, how the ocean has changed over millions of years.
Fascinating. So how do they actually, like, read these sediment layers?
Well, there are tons of techniques. One way is by looking at these tiny fossils called foraminifera.
Foraminifera, those are single-celled organisms, right?
Yeah, and their shells, they record the chemical composition of the ocean at the time they were alive.
Uh-huh. Clever little creatures.
Right. And by analyzing those shells in different layers of the core, scientists can see how, say, the ocean's pH has changed over time.
So we're not just seeing what creatures lived back then, but we're also getting a sense of the environment they lived in.
Exactly. And get this, by studying foraminifera, they discovered that the ocean's pH has fluctuated naturally over millions of years, gone up and down. But the current rate of acidification, due to human activities, well, it's happening way faster than anything in the past.
Interesting. And concerning, I imagine.
Yeah, definitely.
Okay, so mass spectrometry is telling us about the ocean's present, and seafloor drilling is revealing its past. But, like, how do these two very different techniques work together?
That's the cool part. They complement each other perfectly, giving us this much richer picture of the ocean.
Okay, paint me a picture. Give me an example.
Say we're studying rising sea levels today. Pretty important stuff, right? Well, with seafloor drilling, we can go back and see how sea levels have changed naturally, over centuries or even millennia.
So we can compare the current trends to the natural cycles of the past and see if we're outside the norm.
Yeah, and figure out how much of that change is, well, because of us. And then we can use that information to, predict future sea level rise and help coastal communities prepare.
Wow, powerful stuff.
Right. It's like comparing a snapshot to a full-length film. Seafloor drilling gives us the whole story, the context. Mass spectrometry gives us the close-up, the details.
Together, they tell a much more complete story.
Exactly.
Well, this deep dive has certainly opened my eyes to the incredible power of these techniques. It's amazing to think that we can analyze the ocean's chemistry in real time and also travel back in time to understand its history.
It really is mind-blowing.
And who knows what other mysteries of the deep we might unravel in the future, right? With technology constantly advancing, maybe we'll uncover new life forms, lost civilizations, even clues about the origins of our planet. I mean, the possibilities seem endless.
The ocean is full of surprises, just waiting to be discovered.
It always is.
Well, that wraps up our deep dive for today. Hope you enjoyed the journey. And who knows, maybe one day you'll be the one making the next big discovery in the ocean.
Keep exploring.
Until next time, happy diving.